Alright, let's see number one question. Prove that lim as x tends to 0 of sine x over x is equal to 1. That is number one. How do we do it? We say, since my x, before I start doing this, let's test this and see the possibility. If I should put sine 0, what will be my result? That's the question you must ask first. Sine 0, if you put your calculator very well, you get that sine 0 is what? Is 0. And then here, we put 0 here, this becomes infinity. And the question is, how do I even know that what I say is correct? We have provable facts that using sine x equal to x minus x cubed over 3 plus x raised to power 5 over 5 factorial plus ellipsis. If I put 0, sine 0 becomes 0 here, 0 here, 0 here. So everything will end up becoming what? 0. That's our first observation. Secondly, since this doesn't work, we use this. But when we are using this, that is why we are going to be ready to make do some divisions and other thing. But we can still say, okay, fine, there are two methods to solve this problem. One method is this, is what I want to do now. The first method is saying that lim, using the operator rule, substitute this into this, we have the lim of x tending to 0. For what? Sine x becomes x minus x cubed over 3 factorial plus x raised to power 5 over 5 factorial plus ellipsis, close in bracket, divided by x, this x. So that will give us lim as x tends to what? 0 of what? This entirety, this comes into, it becomes x over x minus x cubed over x 3 factorial plus x raised to power 5 over x 5 factorial plus ellipsis. Right? Mash it in. We have that this becomes lim for x tends to what? To 0. And then we have what? We have this as 1 minus x squared over 3 factorial plus x raised to power what? 4 rather, over 5 factorial plus ellipsis. If you observe with the trend, it's coming that if I put x equal to 0, all this becomes 0. So I'm having that what? That lim for x tends to 0 of this whole thing is what? Is 1. Proved. This one way of proving this. Another way of proving this is just follow for part 2 and see what will happen here.